anything. So let's jump in here and see what we've got. The exponential function, oh shoot, I need to take attendance first. Okay. Riley. We don't know where Riley is. Okay, so the exponential function is defined now. Let's not let this confuse us. The key to exponential behavior is the size of this number, right? So let's think about this. Anybody know the decimal approximation for E? 2.718. And the decimal approximation for pi is 3. So this is 2 over 3, which is less than 1. So wouldn't this graph, or this equation I mean, graph as a decay situation? All right. So which of those is right? The rate, you said C, let's read it. The rate of change is negative and the graph is concave up. What's rate of change? Slope? Slope negative in that picture? Yep. And concave up. Beautiful. You guys are brilliant. Okay, number 2. The graph of the piecewise linear function is shown. Okay, so what is drawn is G. Let F be the inverse of G. Okay, so when he talks about F in this problem, he's talking about the inverse of G. All right, G of negative 2. All right, let's see. What's G? This is G, the picture's G. What's G of negative 2? 1. So this right here is 1. So G of 1 is negative 1. Perfect. You guys are geniuses. You're great. You're on target. Ooh. F of negative 4. I heard somebody say 4. I'm just going to write that down. You like that answer? Now, if that's true, then G of 4 has to be negative 4. So I'm going to look at my picture. Is G of 4 negative 4? Yeah. Yes. So the inverse of negative 4 is going to be 4. Very, very good. The minimum value of F now, that means the smallest Y value for F. What do you think? What? Negative 5. Why do you think negative 5, Anna?
Because that's the smallest X value.
Exactly. Remember, guys, if we're looking for the smallest Y of the inverse, then aren't we looking for the smallest X of the original? And that's why she said negative 5. All right. Let's try 5, 6, and 7 with your partner. And we'll get the answers up here and we'll compare them. 5, what did you guys put here in your big parentheses? Remember, as Xander so eloquently said a moment ago, you gotta have a log. You can't just get rid of the log. So when you mash it all together, it's one logarithm. And what goes in here? What do you got? X to the third, z to the fifth, over square root of y to the 1/2. Square root of y. Is that okay with everybody? All right, describe the end behavior. Be careful. Be careful. What's that first picture look like? It's a negative logarithm, and it has an asymptote, a vertical asymptote at -2. So, we okay with something like that? So when you describe the end behavior, you're not going to have what we normally have, which is x approaches -infinity. That is what we have. In this picture, x is approaching -2 from the right. That is as far left as we can go. And then you have on the right, you are going to infinity. So is the setup for my end behavior okay with everybody? All right, so what are the values then? What happens as we get closer and closer to -2? Positive infinity. And as we go further and further to the right, we are going negative. Perfect. B, I tried to get tricky, but I'm sure I didn't trick you. What does that negative do? Flips that, doesn't it become 5/3? So what have we got? A regular exponential. What happens as we head to the left? What are we doing? Getting closer to 0 from the top. Beautiful, beautiful, beautiful. Coming in. And then what about the other way? Positive infinity. Perfect. Again, beautiful. Beautiful. Describe the rate of change of these. Okay, so I got my pictures. So, rate of change. Would you say this is positive or negative? Negative? Would you say that it is increasing or decreasing? The rate of change. The rate of change. Increasing. Why? Concave up. Perfect. Perfect. How about this one? Would you say this rate of change is positive or negative?
Positive.
Positive. Would you say it's increasing or decreasing? Increasing, because again, it is concave up. Yes. All right. Which of these are equivalent statements? I don't know. Spend a moment on this. See if you can find any matches. this one to match. But I think I have some more matches up there. Anybody see any other ones?
3 times 81.
What?
I think this one is the 3 times 81. To the X.
This guy right here?
Yes.
What does he match?
I got that as the same thing as the 243 to pick that.
Here?
Yeah.
Now, we need to be careful, guys. Let's talk about this for a second. Let's talk about this. First of all, 243 is 3 to the 5th power. So I can rewrite that as 3 to the 5th to the x, and then multiply those exponents and get 5x. Would everybody agree with that? Now, I can do the same thing here. 81 is 3 to the 4th. So now I have a 3 times 3 to the 4x. But what happens to these exponents? These exponents don't make a 5x. What do they make? What do I do with them? Add them, 4x plus 1. So this guy right here is 3 to the 4x plus 1, which means he matches the one he's right next to. And what about this? Isn't that also 3 to the 1 plus 4x? And what happened here? I changed my 9 into 3 squared. So I got 3 to the 4x there. Is that one the same also? So I got a couple different kinds of matches. What do you think about that? Is that okay? Good? All right, last one. I need you to get out that other review sheet, the one I assigned over break. We have not talked about it yet, so go ahead and get that out. We'll talk about it now. The one I sent you in, they gotta figure out how to make school be usable during J term. I think I gave you the answers to this sheet too. I mean, the bigger one, the one you did over break, I gave you the answers, I think. Okay, so this is the phone problem, and you were writing a logarithmic regression. Does anybody happen to have that written down? The logarithmic regression? No? Well, we need it. So I'm gonna have to find it here real quick. Yeah,
I have it.
you have it, God bless you.
What is it? 12.704 plus 28.520 elements.
Thank you very much, Anna. So, Anna typed in, as hopefully you did also, all this data on this problem number 17. She did logarithmic regression on it and ended up with that as the answer. Okay. Now, when on our new review sheet, last question says, find the residual value for 2000. Now, how do we find a residual? Who remembers how we calculate that by hand? Actual minus predicted. So if we go to our chart, we're finding the residual for 2,000. So the actual percentage is 63.8. And then the predicted would come from our model. And what's my X? My X is in years, starting with 1, 2, 3, 4, 5, 76. So I got 63.805. So my residual is, what is that, negative .005, did I subtract right? Everybody okay with that? Now what does that mean? It means that my model overestimated, but not by very much, right? Let's qualify that. It actually really was pretty darn close, right? But it did overestimate just a tad. And let's talk about this for a second. A good model will overestimate some and underestimate some, right? Yeah, okay, perfect. All right, find a linear regression for the data. All right, so this is gonna take a minute. We're gonna have to go back. I don't know when you did this. It might still be in your calculator. Mine is not. So let's go ahead and put the data in, and we're gonna do a linear regression. So you remember how to do this? Help each other if you've forgotten. Remember, X is not the year. X is the time in years starting with 1 for 1995.
Don't, like, type in. Yeah, I'm pretty sure.
Okay, has anybody gotten it? Did anybody come up with this? They get that? Perfect. All right, so then we're gonna find the percentage of Americans with cell phones in 2013. So what X would 2013 be? 19. So let's use our Y button. Let's just do this. Let the calculator do all the work, no round off. Yeah, 108.386. Did you? Whoa. Something's crazy. This is right, but wacky. Because why? What is that number? That's a percent. That's a percent. So, can somebody explain to me what's happening? Why did the linear model fail?
Because cell phone growth was exponential.
Okay, I gotta be careful because an exponential model would fail also.
Like, cause the line keeps going up, but like a lot eventually.
Exactly. You guys, exactly. These are percentages, okay? This isn't like raw numbers. These are percentages. So percentages are allowed to keep going up, but can they just keep going up infinitely? No, don't they have to level off? Yeah. So your logarithmic growth levels off. Now eventually it's gonna fail too, because it does keep going up. Actually, probably the best model for this would be what we call a logistic model. And a logistic model has this kind of growth. So it actually has a cap on it. Those aren't part of our conversation, but that probably would be the best kind of equation to use. Anyway, good? Okay, that review sheet's done. Tell me this, was there anything else on that review sheet we just referenced? We just did number 17. Was there anything else on this sheet that you felt like you couldn't do? Or you did it and you checked your answer and we didn't match? Which could mean you're still okay. I don't know if all my answers were right or not. Oh my. Yes, Addie. 15 D. So this is a little logarithmic inequality. And anytime that I am in logarithm land, I have to be very aware of domain. Right? So, right from the get-go, I gotta make sure that x squared plus x minus 5 is positive. And x plus 4 is positive. So before I even start messing with it, doing anything, I gotta, or at least, maybe not first, but at some point, I have to double check this. Because whatever x's I choose, have to make this positive and this positive. Now, this one's easy. X is gonna have to be bigger than -4. So if I'm on my number line doing a sign chart, then I'm over here. I cannot be over here. Everybody good with that conversation? All right, so let's check this one. This is a little quadratic and it doesn't factor. So I'm gonna quickly do the quadratic formula on it. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So what are my two roots? Negative 1 plus root 21 and negative 1 minus root 21. Would you agree with me? Okay, I need to put those on my number line up there. I'm going to kind of decimally figure out what they are. .79 and the other one is negative 2.7. Now, I want you to think about this for a second. I mean, I don't know how it's easiest for you to think about it. If we had a nice little factorable quadratic, and we had roots at 2 and 3, if that has to be positive, if the product of those two has to be positive, where does that happen on the number line? That when I multiply things together, I get positive, positive. Well, or negative, negative. If I pick a number less than 2, won't both of these be negative? And wouldn't that mean that worked right there? And then if I pick a number bigger than 3, won't they both be positive? And so that works over there. And if I pick a number in between, like 2.5, then one would be positive and one would be negative, and that wouldn't work. So what am I trying to get you to see? Where on the number line, if I have 2 roots and I want my product to be positive, where with regard to these 2 roots, these are kind of funky numbers, where will I shade? Before the first one and after the second one. So my shading is going to be over here, but remember I gotta stop here, so it's gonna be there or here. So far, those are my acceptable answers. I haven't even solved the problem yet, but that's so far. Are you with me? Okay, now I'm going to solve the problem. So, x squared plus x minus 5 is bigger than x plus 4, which means x squared minus 9 is bigger than 0. Here we are, right where we were a minute ago. We were going to shade that. Where are those answers going to be? Before negative 9, that's a greater than. So it's just like the one we just did. So before negative 3 or after positive 3. So here's negative 3. And here's positive 3. And I have to be before this one or after this one. Tell me what my answer is. -4 to -3. And what? Absolutely.
Isn't it greater than -3 though?
You mean here?
Yeah.
Okay, so remember, this said x squared minus 9 is greater than 0. So the factors are -3 and 3. So let's pick a number, -4. -4 would give me negative. When I multiply those together, I get a positive result.
Sorry,
That was a major problem. Good question, Addie. Thank you. All right, who else? Who else had a question?
You do the one about it, Steve.
Above it? Yep. Remember, you can never solve a logarithmic equation if you have two logarithms on one side. So you've got to put these two together. That'll be easy enough. How are they going to go together? We practiced this a minute ago. It's just going to be a division. Now, you can't drop the logarithm. It's not like this problem where we had one on each side. So we're gonna have to log rule that. So this is gonna say e squared equals x over 3. So x equals 3e squared. Yep. Yep. Now, what is freaking her out about question number 11? The bases don't match. But I have said, it's been weeks ago, but I have said over and over and over again that you can change any base into any other base. Remember your change of base formula. It says something like the log base x of y will always be the log of y over the log of x with whatever base you want. Okay? So, if we have this, and I would rather not have this, I'm going to change this into a base 9 so it matches, then this will become the log of x over the log of 3, and I'm choosing to use base 9. Now, what's the log base 9 of 3? One half. So isn't this really, since that's a half divided by a half, isn't this really 2 log base 9 of x? Now what? You still can't drop them. There's still something you gotta take care of. What do we have to take care of now? Where does he go? Exponent. Now can I drop them? Yep. So 8x minus 15 equals x squared. quadratic. Lula, you keeping up here?
Yes.
I got 5 and 3. I need to go back to my original problem now and make sure they're both okay. I think they're okay. So one more time. Any logarithm, let's say you have log base 5 of x. That can be changed into any other base that you want. Log 5, excuse me, log x over log 5. And then just stick in whatever base you want. So if you need a base 7, stick in base 7. Okay? Perfect. Who else? Sandra, don't be bored. There it is.
Dial.
Can you do 8?
8.
Oh, yeah.
Prove that they're inverses. So the only way to prove that they are inverses is to put them in composition with each other. So in other words, f of g of x has to be x, and g of f of x has to be x. Okay? That's how you prove things are inverses. You make a composition of them, and if you start with x, you end with x. Okay, so what are my functions? So this is gonna be this one first. So I plug in g into f. So 2 times the square root squared minus 3. So I plug g into f. So what have I got? 2 times x plus 3 over 2. Oh, that looks good. Would you agree? All right, now I'm plugging f into g. So that's 2x squared over 2 squared x squared is x. I guess they're inverses. Right, you remember that now? What else? Anything else? Yep, ma'am.
So is when it says to prove it, your answer is the composition?
Yep, your answer is that the composition works out to be x. So, in other words, when you make the composition, everything cancels but the x. Both ways, f of g and g of f. Okay? Joey, did you have a question? Okay. Anybody else? I want to make sure, I mean, not that it's hard, but I know it's a quiz question, and we haven't really talked about it in a long time. Problem 13. Can everybody find the inverse? So we switch our variables, and this is no matter what. No matter what we're finding the inverse of, we're going to switch our variables and then solve for y. Now, these can get a little bit tricky sometimes if we're not careful. So I multiplied this over here, got rid of my fraction. Now, if I'm solving for y, what am I going to have to do? Get all the y's on one side. Yep, very good, Bryce. And then I can factor them out. And divide. So that would be my inverse. and it's not very long. Come on, don't act surprised.
I'm not surprised.
You've been reviewing, Xander.
With our final semester, we allowed to come in like office hours and look at that.
Absolutely, absolutely. My goal is that after we're done with unit 3, and we hopefully have like a month to review, that will be one of the things we review with, is your exam. We gotta get through unit 3 first, which is our last unit. Precal AP only tests 3 units. There's 4 units in the course, but they only test 3 of them. So we're doing 3, and then we are reviewing, and then getting 5s, and moving on. Right? All right. Anything else? All right, yesterday in class, I'm gonna stop, but yesterday in class, we began a review sheet. We had a little short period, so we didn't get through the whole thing. C period had the lunch period, so we got through the whole thing. It's videoed, so if you want to finish that review, that's completely up to you. The one we started yesterday. Between